My name is Phil with the Masonry Institute of Michigan, and today we are going to talk briefly about layout for masonry walls, specifically concrete masonry, and we'll do brick in another episode here on our YouTube channel. But today we're going to look at modularity and its impacts on a concrete masonry building. So I used Revit and Masonry IQ to put together a pretty simple single white masonry building. So maybe we have some garage doors in the back and an office area up front with some door and window openings in it. And specifically, we will look at this elevation here for the purposes of our discussion today on modularity and dimensioning. And so looking at it, it looks fine. I specifically made some errors when I laid this out so we can talk about some of the different rules we'll follow as we lay out our concrete masonry walls. So if we look at our elevation here, I have a dimension string across the top, which we can see up here. And I also have our doors and our windows dimension. And the nice thing is with using Masonry IQ, it's actually going to tell us where we have an issue in terms of cuts. And so if you look over here, and we zoom in, it's telling me that we have to cut this unit 12 and 3/16 of an inch. And so that means that up this wall elevation, we are going to have to cut all those units to allow for our overall dimension here to equal what I had laid out, which obviously we don't want to do that. That's going to affect productivity and cost. And additionally, we are going to have some small pieces here on the end, which typically we're going to use a vertical rebar in the cell next to a movement joint on either side, or at locations such as this where we have a transition from a shorter wall height to a taller wall height. And with this decreased width here, we likely cannot fit a rebar in that core, so we'd have to go over 1 unit to place that vertical reinforcing bar, which could potentially be an issue. Other issues that I have here, so typically what we're going to do with masonry walls, we're commonly going to have a 7-foot door, so that's going to be 84 inches will be our door height, and we can get a 4-inch head on that door frame. And with that, we have a nice modular layout. So our entire rough opening here will equal 11 blocks, if you count them, which will make that 7-foot door height, which again is our 7-foot door plus a 4-inch head on that door. And typically we will have a rough opening width for our doors, a single swing door of 3 foot 4 inches. They also make 2-inch head heights for our standard 7-foot doors. And so if we ordered the wrong door, then we would have an issue here where somehow we need to make up that 2 inches at the top of our opening. And so what they typically do probably is cut some of the units to move this lintel down, but not a good situation. So we want to make sure we have our doors that we're ordering with our modularity in mind. So typically our rough openings for a standard door, again, will be 7'4" by 3'4". Additionally, I had moved this door specifically to show you the impact of overall dimensioning. So I offset it from this window 3 foot 8 inches, which looks like a modular dimension with that 8-inch number. But however, if we look in at this door, they would have to cut all these units on both sides of our door in this case. And again, we run into that same issue where on the right-hand side, we have a very, very small piece of a unit to accommodate that overall dimension of our wall. And so similar to our movement joints, corners, things like that, now we can't fit a rebar obviously in this core because we don't have a continuous core up that door. So we would have to offset our vertical rebar to the next core and somehow try to grout this entire area. But obviously with this unit being so small, it's not going to look all that great. Nobody's going to be pleased with the end product. And so there's a few tweaks we can make to this elevation to make everything work out in modularity. And so if I take a screenshot of this and I'll open up a whiteboard here so we can draw on it. And let me get rid of this old one that I had here. So our overall rules. So overall, our nominal dimensions for masonry are in increments of 8-inch going up the wall, and usually our standard units are 16 inches wide nominally. And so in terms of overall dimensions, we have a couple simple rules we can remember here. And so if I zoom in here, we can use this as an example. If we have an odd number for our first part of our dimension, so in this case, we have 5 foot, we need to have a 4-inch number to make that work in modularity. So 5'4" would be modular, 3'4" would be modular, 7'4" would be modular, etc. If we have an even number in the first part here at our feet, such as 6 foot, then that second number, our inches, either will be an 8 or 0. So 22 foot would be a masonry modular number, 22 foot 8 would be a masonry modular number, 23'4" would be a masonry modular number. Again, if this first number is even, this will be a 0 or an 8. If this first number is odd, this will be a 4 to maintain overall modularity. So our issues here on this elevation, we have 5 foot 2, which obviously is not a modular number. So if we moved this to the right 2 inches, that would make that 5'4", which would be a modular number. So that would clean up that part of this dimension string. And similarly, we have 7 foot here, or I'm sorry, 7'6" here. Again, an odd number. So we have a 4-inch. So if we move it back 2 inches, we would maintain our overall modularity. So if we actually left this wall exactly where it is, we just accommodated for our modularity with these openings. So we'd shift them all over 2 inches, and then this one, we would have to shift back over, I believe, 4 inches. That would maintain that overall modularity of our wall, because all these other numbers are in modular dimensions. Again, if we're odd, it's going to be a 4-inch number. So our 3 foots and our 5 foots all get 4 inches. And then here we'd have 6'8", which obviously is in coursing. Here again, so this is not a modular number, 3 foot 8 inches. It looks modular because there's an 8-inch number in there. However, like we discussed, if that first number is odd, then that really wants to be a 4. So if we change that to 3 foot 4 inches, that would eliminate all these cuts around that opening. And so obviously that's going to save in terms of productivity, in terms of cost, and especially with OSHA really emphasizing airborne silica, that'll help eliminate some of our cuts and provide a healthier job site. NCMA does have a few tech notes that basically go over what we just discussed. So tech note 05-12 is on modular layouts of concrete masonry. And they go through the different things we discussed about wall elevations, openings, in terms of head heights, sill heights, how much wider they need to be, things like that. It gives us nominal widths here. And it shows a nice diagram down here of all of the cuts that are needed if we dimension in a non-modular layout. And so if we had a modular layout, which they're showing here, there would be no cuts required to construct this wall elevation. However, if we have a non-modular layout, all these shaded units would need to be cut. It's obviously that's going to affect, again, our production and our cost of our project. So a good tech note here that goes through a lot of those different rules. And they have another tech note, which is more for contractors, and that's on productivity and modular coordination, and that's tech 04-01A. And so it talks about how productivity rates are affected by certain things, such as the weight of our units, and you can see that in the chart here. And it also discusses planning and layout, which talks about modular dimensioning. Again, we want to make sure that we are dimensioning with concrete masonry with modularity in mind to provide the best end product. And so both these tech notes discuss that. We showed it in an example today. Pretty easy rule to remember. Again, if that first number is even, the second number is a 0 or an 8. If that first number is odd, that second number is a 4. And that's the easiest way we can quickly look at a string of dimensions and see where we have any potential issues and make sure we are designing with modularity in mind. So thanks for listening, and be sure to reach out with any questions.